Hi students, how are you all? In this video, we are going to start a new chapter of the second year that is called General Principles and Process of Isolation of Elements. Yes, in this chapter, we are going to see the process, how it is used in extracting various elements. And where do we get these elements? In natural case, these elements are present in the earth crust, and in the earth crust these are in a combined form, means they will not be available freely. They will be reacting either with oxygen or either with sulfur present in the so-called earth crust, and they will form their oxides or sulfides. So most of the elements, the metals especially we are speaking, they are present in their combined state. So we need to isolate from their combined state. So the meaning here, isolation, means to free up the particular element from the remaining other atoms or the other elements that are combined with this element, because they are reacted towards them. So once let us get the definition for the word of isolation. The fact that something is separated and not bonded or connected to other things, or we can say other atoms. In this whole chapter, what is our task is to, our task is to isolate some of the important metals that we are using in our day-to-day life. We had got this point, that is the general principles and techniques is the chapter title we had taken. In this principles and the techniques, we apply many scientific and technical processes here, including the chemical reactions. So this entire chapter is also called with one more name, that is called metallurgy, because we are going to study the extraction of metals. We are going to study the extraction of metals. So let us get the definition of the metallurgy. The entire scientific and technological process used for isolation of metal from its ore is known as metallurgy. Now most of us will have a doubt what is meant by a ore. Yes, we will be coming across what is meant by ore and the remaining definitions. So the general principles and the isolation of elements is the chapter heading. In some books this heading is also called with the title called metallurgy. Now where are the elements or the metals we had discussed they are present? They are present in the earth crust. Yes, most of the elements are present in the earth crust. How are they present? They are present in their combined form. They are present in their combined form. In which one is their combined form? Means they may react with sulfide to form the sulfide and with oxygen to form the oxide. So let us see how much distance is this crust of the earth is occurring. We can see the earth contains many layers: the crust, mantle, outer core and the inner core. Our crust, once we observe, it extends from the 0 to 100 kilometers thick. After this we have the mantle, outer core and the inner core. But our elements we present in the crust of the earth. So we can get these elements or the so-called metals by digging the crust of the earth. Now there are many elements, but our case study is related to the most occurring element. We can observe in the pie diagram that you are able to observe here. Oxygen is the highest percentage of element that are present in the earth crust. It is not a metal, but it is present along with other metals in their combined form. So it is the most abundant element, around 46.4 percentage. And the second most abundant element we can find the silicon. It is around 28.2 percentage. And in the pie chart you can find the third most abundant element in the earth crust. How much is that one? 8.32 percentage. That is what we call as the aluminum. So here these are some of the percentages of the elements that are present in the earth crust, and they are not available directly, they are present in the combined form. Our case study now we are going to take especially with one of the metal, that is called aluminum. We will discuss with the remaining metals when the time comes in the particular topic. So let us see what is the third most abundant element in the earth crust. We had already discussed. It is the aluminum. Yes. Does this aluminum occur freely in the earth crust like the gold? No, we cannot say it is freely available in the earth crust like the gold. Here the aluminum is having more affinity towards the oxygen. So it forms the aluminum oxides, or it may combine with some silicon to form the silicates. So the combined form of aluminum with the oxygen or silicon were more cases for the aluminum, but it is not freely available. Let us see some examples where we are using the aluminum. You can have a glance at a shot. In most of the day-to-day life, we are depending on the aluminum. Even the airplane parts we had learned in the first year, which are of lightweight, they are prepared with the aluminum. And the conductance of the electricity, that is also with the aluminum wires. We know the aluminum wire itself, it will be reacting with atmospheric oxygen to form the aluminum oxide, which acts as a protective layer. Hence it is reducing the cost effectiveness also, because it is the third most abundant element in the earth crust. And we have the aluminum foils that preserve the food from undergoing oxidation. Yeah, we have a lot of applications in our day-to-day life with aluminum. So let us start seeing the occurrence of aluminum in the earth crust. How is it present? Here, when we are studying about the earth first we had learned it was the rock, or it is formed from the volcano eruptions. And this so-called aluminum, what we are speaking, we already mentioned, it is in a combined form with the oxygen and silicon, forming the oxides or silicates. Let us see the example here, feldspars. These are not a single components, these are a group of components. In the feldspars, there are three examples given here. Potassium aluminum silicates, Si3O8, and sodium aluminum silicates, calcium aluminum silicates. These combinations, in all these three, if you study individually, the potassium aluminum silicate and sodium aluminum silicate, calcium aluminum silicate, these are all the group of rock forming ptitosilicate minerals that are making about 41% of Earth's continental crust by weight. See, the out of 141% it is taking. So it is what the third most abundant element we see. From these combined state, we need to separate out the aluminum. It's not only that aluminum is present in a combined form with the potassium, the silicates, as sodium silicates or the calcium silicates. It is in a combined form with many other elements also. Let us see some of them. We can give aluminum occurs in the minerals. Here, what is a mineral? Whenever we are going to extract any metal from the earth crust, it is in a combined form. So this combined form of a metal with many other substances, that is so called silicates or the feldspars and many other combinations, we call as the minerals. Some of the examples they are given as the beryl, cryolite, garnite, spinel. We will give exact definition what is meant by mineral. These are the many sources of the aluminum. Let us see what is beryl. It is a mineral composed of beryllium, aluminum, cyclosilicate with the chemical formula B3Al2Si6O18. Here it is included in emerald and aquamarine. These are all many combined states of the aluminum. But among all these combined states of aluminum, we cannot extract the aluminum from all the combined states. We can extract the aluminum from only few combined states. So, what we are going to say is, these all combined states of a particular metal in the earth crust, we are studying it as a mineral. What are we calling it as the mineral? Yeah, before I give the word mineral, please observe the feldspars, the potassium aluminum silicates, sodium aluminum silicates and calcium aluminum silicates. Do you find any carbon component here? We don't find any carbon component. These are all inorganic compounds that are present in a particular ratio. So we are going to say these minerals are the sources from which we can get a metal. These are all inorganic compounds. So see the first point there, a mineral is a naturally occurring inorganic solid with a definite chemical composition and an ordered atomic arrangement. We had seen up to now some examples. In all those them, there is some chemical composition in a particular ratio, and also they are obtained in the earth crust. These are not man-made. These all are, most of them are the inorganic. And where did we get these from? We are getting these minerals from the earth crust. And the process to get a mineral from the earth crust, we call it as the mining. What do we call it as the children? Mining. So we got a new word now. Mineral is a naturally occurring inorganic solid with a definite chemical composition. How do we get the minerals from? We get the minerals from the earth crust by the process of the mining. So let us get the meaning. What is meant by the word mining? In our Kolar KGF, Kolar gold fields, what mines are present? We say we have the mines of the gold. Means a particular mine is having the property to get the particular metal from the mine. So it is the process in extracting of valuable minerals or other geological materials from the earth. But according to our chemistry language, we give only the first definition. What is meant the first definition? Minerals mining is the extraction of valuable minerals. Most of the valuable minerals only we will extract. What is meant by the valuable mineral? The mineral that contains a particular composition of components. From them we are going to select a particular metal that is useful for our day-to-day life. So this is what the definition for the mineral. Mining is a process of extracting the valuable mineral. Example, we had given our Kolar gold field. So these so-called definitions are very important for you. The first definition is called, what is meant by a mineral? Mineral is an component naturally occurring inorganic solid with definite chemical composition. That is called as the mineral. These minerals are extracted from the earth crust by the process of the mining. How are they extracted? By the process of the mining. And now we had the main thing that we got in the previous step. We got many minerals of the aluminum. We had learnt about the feldspars and the many minerals of the aluminum. But all the minerals of a particular metal, they are not useful to extract the metal in a good abundant method. Means when we are going to invest some amount through the process of mining, we must get it in an economical feasible method. Means once you invest 1 crore, you may be expecting to get a 20 crore in your business. So this process of extracting a particular metal from a mineral profitably, the source of the so-called mineral which can give more amount of a particular metal, we call it as the ore. What do we call it as the ore? So the third definition what we are learning is ore. See, for aluminum we had seen many minerals, but from all those minerals we cannot get aluminum in most or more amount. We can get the aluminum from only few of the minerals in a good better amount. So this source from where we are getting the aluminum in a good quantity, we are calling as the ore. Let's get the definition of the ore. Out of many minerals in which a metal may be found, only few are viable to be used as source of that mineral. Such minerals are known as ores. What do we call those such minerals as the ores? Yes, we had the ores for aluminum, two main ores. There are many ores, but presently we are discussing only with few ores of the aluminum. What is the first ore we are getting here? It is called as the bauxite. Al2O3 3H2O is the formula for the bauxite. It is the best ore to extract the aluminum in more amount. So the ores are the compounds from which we can get more amount of the metal. See, mineral will be an ore, but ore cannot be a mineral. Now we had the one more ore of the aluminum. That's what we call kaolinite. What do we call it as the kaolinite? Its formula is Al2OH4 Si2O5. So these are the two ores of aluminum what we are going to discuss now. Now let us observe, are these ores very pure? We cannot say the ores from which we are getting a particular metal, they are pure. They contain some impurity. Only some of the ores are free from the impurities. So these impurities that are present in the ore, we are going to call them as the gons. What do you call as the gons? The impurities are nothing but they are the clay or the sand particles that are present in the ores. So let us give the definition for the gons. See, observe there, rarely an ore contains only a desired substance. Means most of the ores are in a combined form with some earthly impurities. What are the earthly impurities here? They may be sand or they may be clay particles. So these are known as the gons we discussed. So give the definition. When we give the definition here, we call ore is usually contaminated with earthly or undesired materials known as the gons. So first our point is to remove the earthly material from the ore. Then we can go for the remaining processes of extracting the metals. That is what we call as the metallurgy. Now there are many processes here. There are many processes here in extraction of the metals. They can be studied in a step-by-step method. Observe there, the extraction and isolation of an element from its combined form involves various principles of chemistry. Yes, we are going to apply various principles of the chemistry here. These various principles, there are many steps here. We will be dealing about these steps one by one. There are mainly 3 steps in extraction of metals from the ores. The 3 steps are very important, which will be discussed individually now. The first and foremost step is the concentration of the ore, and the second step is called isolation of metal from the concentrated ore, and the last step is called purification of the metal. Once again, let's recall, children, what are the 3 steps that are majorly involved in extraction of a metal from the ore. The first step is called concentration of the ore. Second step is called isolation of metal from the concentrated ore. Third step is called purification of the metal. Now, what is meant by concentration of the ore? We have already got the point that the ore is not a pure substance. It is contaminated with earthly impurities. Now, the earthly impurities we call as the gons. The process to remove this earthly impurity from the ore is called concentration. It is also called in another names like dressing or benefaction of the ores. So, let us see the definition here. Ores are solid material from which a pure metal can be obtained. Yes, it's true. But in this process, we want to remove the unwanted material. So, this process, let us give the definition. The process of removal of unwanted material from the ore is called concentration, dressing or benefaction of the ore. So, this is the process in which we are going to separate the unwanted material, that is the earthly impurities. Now, this concentration of ore can be done in many methods, but in our syllabus we were given only with a few methods to be discussed, and these are the 4 methods that we are going to discuss with this concentration of the ore. It involves in various steps. We had already discussed this one. The 4 most separating techniques that are used in the process of the concentration of ore are different from one another. Any one method will be applied based on the type of the ore. Okay, what is the first method here? The first method we call as the hydraulic washing. What is the first method we call as the hydraulic washing? Hydraulic washing means we will wash the ore with some amount of water, and the water, when it is applied in an upstream, it will carry up the impurities with it, because the gons particles, those are the dust particles or the clay or the sand particles, will be lighter in weight than the metal. So, this metallic ore will be settled at the bottom, and the clay particles or the sand particles will be floated along with the water. So, this process of removing the earthly impurities by passing the water in an upstream method we call as the hydraulic washing. We will observe the second one, magnetic separation. It is the one in which the ore particle may contain a metallic compound or a non-metallic compound. Let us speak, the ore is a metallic compound and the impurity may be a non-metallic compound. In the crust, these both will be present in a combined form. But once you apply the magnetic field, the magnetic property containing metallic compounds will be separated and the non-magnetic compounds will be left behind. Means we can separate by this method the magnetic characteristic compounds. We'll be discussing the third froth flotation and leaching in detail. In this video, we are going to discuss the hydraulic washing and the magnetic separation along with their diagrams and a detailed view. Yes, let's continue here. So what is hydraulic washing? We discussed at the point. It is the proper process in which we are going to apply the water on the ore and the clay particles will be carried up. Means which is going to settle at the bottom? The ore particles that are heavier, they are going to settle at the bottom, whereas the lightweight dust particles will be carried up. So this is also called as the gravity separation method. Study the points there. This is based on the difference in the gravities of the ore and the gonze particles. What are the gonze particles? The earthly impurities. It is therefore a gravity separation technique. Which one is a gravity separation technique? Hydraulic washing is a gravity separation technique. Let us see here what happens in this process. In one such process, an upstream of running water is used to wash up the powdered ore. With the lighter gonze particles are washed away and the heavier ore particles are left behind. Yes, the example we got here is cassiterite is the tin dioxide SnO2 mineral and the world's primary ore of the tin is processed or it is used to wash up the gonze particles by the hydraulic washing. So we had already discussed each and every technique is used for a particular ore. Hydraulic washing, we are using it for the removal of gonze particles in the extraction of stannous dioxide. This is one of the concentration technique. Let us watch this one now. Do you observe that the ore particles are dropped from a so-called hooper we can call, and once it is forced with water, they are separated back. So this is what the gravity separation technique that we had applied here. And we had one more method, that is the cassiterite. It is also dropped by a hooper. In this, the cassiterite is concentrated by this method. Here it is being washed. The finely powdered ore is first washed here with plenty of water and the gonze particles are separated out here. Lighter gonze particles are carried up and the heavier particles of the ore are left behind. So we just observe the hooper, it dropped the ore particles here and the water force had applied. The force is carrying the gonze particles away. Behind or below we left the ore. And we have the cassiterite separation technique here. In this method, the Wilfy tablets we call, means just these are used in separating the gonze particles. That is table we use. When we wash it with water, the plenty of water, the lightweight ore particles are washed up or carried away and the heavy ore particles have been left behind.